Assalamualaikum warahmatullahi wabarakatuh. I am from Group 5, and in this video I will present to you how breadth-first search can be implemented in a Python programming language. My name is Rafly Rachman. In this presentation, it will be divided into 4 sections. First, introduction. Second, basic theory. Third, problem analysis. And fourth and final, conclusions and suggestions. Let's begin with introductions. In this world of advanced technology, almost everything requires computers. Much of our daily lives are surrounded by computers and the amazing things that they can do. One such things is the use of computers for sorting data. Data sorting algorithms have already been covered by previous papers, and in this presentation, the author will talk about the implementation of breadth-first search method using the Python programming language. We will now get into the second section of this presentation, basic theory. Before we begin talking about how it can be implemented into Python, let's talk about what breadth-first search is. Breadth-first search is a recursive algorithm for searching all the vertices of a graph or tree data structure. It explores all the nodes at present depth before moving on to the nodes at the next depth level. There are many ways to traverse this graph, but among them, breadth-first search is the most commonly used approach. Breadth-first search puts every vertex of the graph into two categories, visited and non-visited. Let's get into the third section of this presentation, problem analysis. We will now get into the main part of this presentation, how breadth-first search can be implemented in Python. Let's look over to the left here at the input/source code. You can see in the top here, the code first needs to have a graph array made so that the code can traverse the tree/graph to visit and queue for the algorithm. Then, at the bottom here, below it, a breadth-first search function will be defined with arguments referring to the visited node, the graph itself up here, and the node elements that the algorithm will traverse. Then, at the bottom here, at this part, a while loop will be made so long as the queue is not empty. As long as the queue is not 0 at the pop here, 0, the queue will pop the number node towards the M next to print here. Then the print function will show the numbered node at the output screen in the end. The next section of the code will be the algorithm searching for the neighbors of the visited node, down here. Then it will check if the visited node, in this case M up here, has already been visited or not. If the queued neighbors are not visited yet, then the condition written at the not and in function will be satisfied and will append the queued neighbors as visited. This will loop until the queued node returns as 0 or empty. Then the loop will discontinue. Here's the output/result. You can see that the while queue here and the M that is printed just below while, it will show the queue, and then eventually it will print the visited nodes. In this case, like 5, 3, 7, 2, 4. As shown on the graph here. This is also at the end here, visited append neighbor 537248, and it will show the queue. This will continue until the queue is 0 or empty. And finally, we will get into the conclusions and suggestions. In conclusion, BFS is a traversing algorithm where you should start traversing from a selected node, source or starting node, and traverse the graph layer-wise, thus exploring the neighbor nodes which are directly connected to the source node. BFS puts every vertex of the graph into two categories, visited and non-visited. Non-visited could also be Q, shown by the code before. And here's the author's suggestion. The author suggests that the reader uses BFS as a method of graph traversal due to its simplicity and ease of use. Implementing it using the Python programming language is also a recommended method of implementation, as Python is all-encompassing and will fit the need of coding using BFS. That is all that I can present to you today. I do hope that my presentation can bring you knowledge and insight into BFS and how it can be used in the Python programming language. Thank you once again. Assalamualaikum warahmatullahi wabarakatuh.